You and your only friend, Bud Tugley, are conducting an experiment. You place 3.20 moles of PCl5 into a 2,000 milliliter flask. What are the equilibrium concentrations of the reactants and products? The KEQ value at this temperature is 1.20. So in this problem, we're going to be using an ice table, we're going to be creating an equilibrium expression, and we'll be using the quadratic formula. So your first step would be to write the reaction, and then balance the equation, and then construct an ice table. Now let's plug in what we know. They only give us information about the reactant, nothing about the products. So at the very start of this experiment, we're placing 3.2 moles into a 2-liter flask. So remember, this is concentration, 3 moles in 2 liters. So 1.6 molar is the concentration. And initially, like we mentioned, we don't have any concentration. There aren't any products formed yet. Now, in any reaction, we can expect the concentration of the reactants to decrease and the concentration of the products to increase. We don't know by how much the concentration will increase and decrease, so we're just going to call that x. Notice that the values are x, x, and x because the coefficients are 1, 1, and 1. Now, if we begin with 1.6 and the concentration decreases by x, at equilibrium, we should have 1.6 minus x. That's how much we should have. And the concentration of our two products at equilibrium should just be x. Now the next step will be to set up an equilibrium expression. That's the concentration of the products divided by the concentration of the reactant. And it's not just any concentrations, remember, it's the concentration at equilibrium. So let's plug in what we know, x and x. Now we can simplify that. Do you remember what x times x is? It's not 2x, it's x squared. All right, so we're going to be carrying this expression over to the next page simply so we have more space. And remember, they give us the k value, it's 1.20. Okay, let's go ahead and plug in the k value. It was 1.20. Now, we want to start solving for x to get x by itself. So to do that, we're going to multiply both sides by the denominator. That leaves us with an expression like this. Now we can't quite use this in the quadratic formula. We need to get x on the other side. So let's subtract x squared from both sides. Now we're in the ax squared plus bx plus c equals 0 form. So it's okay to use the quadratic formula. So let's carry over this expression to the next slide. All right, so this will be a, b, and c. So let's plug in a, b, and c into our quadratic equation. All right, now let's simplify. Now there's going to be two values for x. You should discover that the two values are minus 2.11 or 0.910. Now it's not possible to have a negative value here for x. So it turns out this will be our only reasonable choice. So this x is going to be by how much the concentrations change by. So this was our ice table. So x equals this value. So we want to know how much we have at equilibrium. That's our goal. So at equilibrium, let's plug in the x value for those three x's. And that should tell us the equilibrium concentration. PCl5, the equilibrium concentration is equal to 1.6 minus x, and we established that it should be 1.6 minus this value. This was the x we solved for using the quadratic equation. So ultimately, our concentration of PCl5 at equilibrium is 0.69 molar. Now the concentration of PCl3 and Cl2 should be the same because they're both X. And we know what X equals. It equals this value here. So this is the equilibrium concentration of our two product.